Hey, ladies and gentlemen, in section 3.3, we're looking at direct variation, and that is having to do with linear relationships. A linear relationship is a direct variation when the ratio of y to x is a constant m, and that is the same thing as slope. So it's saying when the slope is constant and we have y varies direct with x. And now we have looked at this already. It's the ratio of y to x staying the same throughout the problem. And we've looked at that before as proportional. Because direct variation is proportional, it does mean that the graph is always going to pass through the origin. And remember that the origin is the point 0, 0. The equation for a direct variation comes in the form of y equals mx. Now what that means, y is your output. We've talked about that. M is the slope. And x is your input. Again, m is the slope. We also know slope as rate of change. We also know slope as y2 minus y1 over x2 minus x1, or the change in y over change in x, or the rise over run. Those are all ways to describe the same thing, slope. In this first example, the amount of money Robin earns while babysitting varies directly. So that phrasing tells you that it's proportional, and it tells you that there is an equation in this format, y equals mx. And we're supposed to determine the amount that Robin earns per hour. To determine the amount Robin earns per hour, the unit rate, find the constant of variation. That is yet another way to say slope. Notice that the time in hours is your x. When we're dealing with time in these situational problems, it is almost always your horizontal or x-axis. And then the other one will be your y or your vertical axis. So because we're trying to find the constant of variation or slope, we're really trying to find the change in y over the change in x. And so we're going to look at two ordered pairs on the graph. So looking at the graph, we have you can pick any two ordered pairs. I'm going to pick some ordered pairs that I think will be easy to work with. I'm going to pick 0, 0. And then I want to pick one along the line that falls nicely on the grid. So it doesn't really matter which point you pick, but I'm going to pick one that I feel falls nicely on the grid, and I feel like that crosses a good, easy spot to read right there. And so that is the point 430. And then we put that into our slope formula, where I'm going to take the second y minus the first y, and the second x minus the first x. And so I get 30 over 4. And that is a way to represent the slope, but we do typically want it to be in lowest terms. So we would reduce that, and if we're trying to find the constant of variation in this story, we usually want per hour. So they're asking for 1 hour. So I'm looking at, okay, how do I change that 30 over 4 into something over 1? A couple of different ways I could do that. I could solve a proportion where that is my missing value there. But instead, I'm just going to say, okay, equivalent fractions, I can divide the denominator by 4. That means I can divide the numerator by 4. And 30 divided by 4 gives me 7.5. So that means it's going to be $7.50 per hour. So looking at that per hour means for 1. And the slope is 7.5 over 1. For this Got It problem, we're taking a look at a skydiver. 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. So we've got 2 minutes going with descending 1,900 feet. And after 5 minutes, he descends 4,700 feet. The distance varies directly, so again, that's telling you it's proportional, and that's telling you y equals mx is the equation. With time, at what rate is the skydiver moving? So we're looking for the rate, so we're looking at feet per minute, so looking for feet per minute if we're looking for that rate. So because rate and the constant rate and slope are all the same thing, again, I am really looking for the change in y over the change in x. And we're going to take the information from the story and make 2 ordered pairs out of it. We're looking at 2 minutes going with heading down 1,900 feet. So my first ordered pair is 2, negative 1,900 is descending. And then my second ordered pair is 5 and descending 4,750 feet. So that would be 5, negative 4,750. So I've got 2 ordered pairs there. Using those 2 ordered pairs given to you in story form, find the change in y over change in x and enter it on Edpuzzle. You should have taken negative 4,750 and subtracted negative 1,900 over 5 minus 2. That's going to give you negative 2,850 over 3. And if we reduce that to a unit rate of feet per minute, we get negative 950 for 1, or down 950 feet per minute. In this example, the cyclist can ride 3 miles in 0.25 hours. So assume that the distance biked in miles, y, so notice they're telling you what the y is your miles, varies directly with the time in hours, x. And so we're looking at miles as the y over hours, the x. And the situation can be represented by y equals 12x. So that is that direct variation equation. And graph the equation. So they're looking at options. You can make a table of values. That's done for you. You make a graph. That's done for you. But again, you're really kind of looking at that ratio. And if it's a direct variation, that ratio doesn't change. So they're giving it to you as 3 miles in 0.25 hours. And if we want the ride per hour, then that means we want the hours to be 1. And so we're looking at how do we get from 0.25 to 1. And to do that, we would multiply 1/4 of an hour times 4 would give us 1 hour. And that's how they're getting that 12. And you can see that's evident right there in that equation. And so the rate is 12 miles per hour. In the next Got It, we're looking at a grocery store selling 6 oranges for $2, and we're assuming that the cost of oranges varies directly. That's that equation, y equals mx, with the number of oranges, and this situation can be represented by 1/3, y is equal to 1/3 x. Graph the equation, and what is the cost per orange? So there's a couple ways we can look at that. First, we want to graph the equation. We're looking at the number of oranges as our x value and our cost in dollars as our y. Now they give us only really one ordered pair, which is 6, 2. And so we're going to go across to 6. So I'm thinking about going across to 6, up to 2, and putting my dot. I'm going to get rid of the other stuff there. And but because it tells us it's very directly, and in this situation, of course, it makes sense, that if we don't buy any oranges, we don't have any cost. So 0, 0 is also an ordered pair there. 1, because it varies directly, and 2, because we don't buy any oranges, we're not going to pay anything. And so then we can use those 2 points to create a line for our graph. Now the other thing we are supposed to do is determine what is the cost per orange. Now we've already been given some information about cost and oranges. So let's set up a ratio of cost to oranges. And that ratio in the story is $2 for 6 oranges. And we're looking for the what is it for 1. And we can put a variable in there. And this is where kind of last year's, you can, again, use division, but you can also think back to last year's proportion solving. Remember, you can cross multiply, so that gives 2 times 1 is equal to 6a, or, oh, if we're dealing with oranges, so just use a so I don't get it confused with a 0. And that's 2 is equal to 6a. And then I'm dividing both sides by 6 to solve that proportion. And that's going to give me a is equal to, or approximately equal to, 0.33 repeating. And so it is about 33 cents per orange. In our last video example, we're looking at distance y in miles covered by a rabbit in 8 hours can be represented by the equation y is equal to 35x. So that goes with the rabbit, and we can see that down here as well. And then the distance covered by the grizzly bear is shown on the graph. So the graph is the bear, so I'm just going to label that. And our job is to compare to find out which animal is faster. So we need to use the graph for the bear to figure out what the equation, or at least the rate of change or the slope for the bear would be. So if we're looking at the rate or the rate of change or slope for the bear, then we want the change in y over change in x from this graph. And they do give us 2 ordered pairs to work with. So I want to take the second y value and subtract the first y value. And I take the second x value and subtract the first x value. And I find the rate for the bear. Enter the rate for the bear on Edpuzzle. You should get 30 over 1. And so that gives us the equation for the bear as y is equal to 30x. And because the rabbit has a bigger rate, the rabbit is faster. So we will continue to explore slope in the next several days. If you have any questions, please let me know.